Okay, so let us quickly debrief about the homework, okay, the chapter 4 homework 2. Now, if you look at it, you will realize that, okay, it would be the multiple choice question for, there are two multiple choice questions, and the answer for both multiple choice question will be D. And you may realize that in fact, some part of the statement it is correct, but some part of the statement in fact is incorrect because or it's still correct, but it cannot explain the previous statement. Now, let us quickly have a look on what's going on in each question. So for question number one, it asking about which statement about the factors affecting the enzyme activities are incorrect. So when you look at it, you will realize that for the first statement, the low temperature, okay, the low temperature decrease, okay, the enzyme's activities, okay. So yes, definitely, the low temperature will decrease the enzyme's activity, okay. This statement is correct, but okay, then you will realize that it is because of the enzymes are denatured. Remember, the enzymes is not denatured under a very low temperature. They are just inactive, okay? They are just inactive. Then, okay, for the high temperature, okay, of when we try to place some enzymes into a very high temperature pot and or into a water bath, etc., then you will realize that in fact the enzymatic reactions or the enzymatic activities will reduce. Definitely, it is also correct. Okay, under the high temperature, it's also correct. But remember, that is not because of the enzymes and substrate molecules cannot collide with one another. In fact, they are collide much more frequently. They can collide with each other, but they cannot form the enzyme substrate complex. So what does this mean? For example, okay, this is an enzymes, okay? Before we try to apply the high temperature. Now, it got a specific, okay, specific active site. Now, for this specific active site, it has special shape and it will only fit that particular substance to fit into it or the particular substrate to fit into it. But then, okay, after the high temperature, the active site no longer in that shape. So in this case, it cannot fit the original substrate. As it cannot fit this original substrate, it cannot form the enzyme substrate complex. So therefore, it will not form the product at all. And this will reduce the enzymatic reaction. And we will say this as the denature. Okay. So in this case, the same thing happening. Rather than the enzymes and substrate molecules, they cannot collide with each other. They can still collide with each other, and even they will have a faster speed in colliding with each other. But they cannot fit towards to the enzymes. The substrate cannot fit towards to the enzymes due to the enzymes has already been denatured under the high temperature. Next, the unsuitable pH decrease the enzyme activity. Definitely, yes, okay. But then, okay, it don't only decrease, but it may even stop the enzymatic activity. This is not because of the activation energy of the reaction become greater, but it's all about the enzymes was denatured under the extreme pH. So therefore, okay, again, they are not because of the activation energy. Rather, they are because of the enzyme denature. Okay, so in this case, the activation energy will not be changed, but they will denature, okay? I mean the enzymes will denature, and this caused the decrease in enzymatic reaction. Now, we have another one, okay? Another question. Tommy investigates the effect of pH on the activity of pepsin, and it is a protein extract from stomach. So in this case, we will notice that, in fact, the stomach, which pH it is, or what type of environment it inside the stomach, we will know it is an acidic environment. As it is an acidic environment, so the students prepare a cooked egg white cube with the same size and also same mass. Now, cooked egg white cube, in fact, it is a type of protein. Okay, so in this case, the pepsin, the enzymes, okay, will digest the protein. So this may decrease, okay, the size and mass and changing solid protein into some soluble protein, or maybe change to some soluble polypeptide or the soluble peptide. So in this case, okay, he tried to test, okay, different peptide solution at different temperature. It tried to test the same pepsin solution at different temperature. Not different temperature, but different pH, my bad. So in this case, we'll notice that the acidic environment for the pepsin is the optimal, okay, it's the best. So in this case, it shall has the highest rate of reaction. If, okay, it is pH 2 to 3, okay? And if we notice that if it has the highest rate of reaction, meaning that the solid protein that convert into soluble protein will be more. More of the solid protein will be converted into the soluble protein, or what we call the peptide. So in this case, this will reduce the mass or the size of egg white cube. Is it clear? So in this case, can you tell me which one shall has the lowest mass? So if you look at it, you will realize that in fact, only D, it has the lowest. And while for the if we increase the pH, in fact, the mass will remain unchanged, or there will be only a small change towards to the mass. Now, here comes a question. Why the mass did not change? This is because of the enzymes. It denature, okay? So in this case, okay, D would be the answer. Now, we have the very similar cases for the structure question, okay, which is very similar to MC question 2. Then in this case, we can see the diagram below shows an investigation of the effect of temperature on the effectiveness of biological washing powder. And there are 6 test tubes containing the equal volume of washing powder solution, a biological washing powder solution, and they were incubated with the egg white cubes in the water bath at different temperature for 30 minutes. So we can see within this setup, what would be the things that we change because it is the independent variable? The variable that we change in the beginning, okay, of the experiment, definitely the only difference or the things that we change would be the temperature. Then what kind of temperature it is? In fact, this temperature would be the water temperature, okay? So therefore, okay, the independent variable would be the temperature of water, okay? Then we move on to the dependent variable. Dependent variable is referring to the things or the variable that we measure. So what means the variable that we measure? We are trying to find out the things that the result would like to reflect. So in this case, if you look at the title, you will see, in fact, it already mentioned that, okay, it already mentioned that, okay, it would be, we are trying to find out the effectiveness, okay, the effectiveness of biological washing powder. So therefore, the dependent variable in this part, rather than writing the rate of reaction, we shall write the effectiveness of biological washing powder. That is because we are not talking about the rate of reaction. We are talking about how effective this biological washing powder is under different temperature. So therefore, the main focus or the results that we would like to reflect or it can give us the answer would be the biological washing powder, the effectiveness it is, okay? How good this type of biological washing powder. So therefore, the dependent variable would be the effectiveness of biological washing powder. Okay. Then how about the measurement of dependent variable? The measurement of the dependent variable, it has the similar concept. But how? How can we know, oh, there will be some digestion occur? Definitely, we will just look at whether, okay, the solid protein can change to the soluble protein, like the peptide. So in this case, where there will be a drop, okay, a drop in mass in size of the egg white cube. So therefore, okay, the measurement, in fact, it would be the mass or the size or the volume of the egg white cube. Is it clear for that? Now, with that, we move on to part BI, and you will see it. I've already highlighted the term describe. What mean describe? We only based on, okay, we only based on the temperature and also the effectiveness of the biological washing powder within the time interval from 0 degrees Celsius to 40 degrees Celsius. Now, we draw a line and then we draw another line. Okay, then in this case, we can see the whole trend. In fact, they are moving upward. So therefore, we can see when we increase the temperature, in fact, the effectiveness or the rate of reaction, it will be faster or slower. Definitely, it will be better effectiveness and the rate of reaction will be faster. So therefore, we can mention in the way that like the increasing or the temperature increase In fact, we are trying to increase the effectiveness of biological washing powder is. Okay. So in this case, we can see when the temperature increase, the effectiveness of the biological washing powder will also increase from 0 degrees Celsius to 40 degrees Celsius. Now, after we have described the curve or the graph, then we move on to the explanation. Now remember here, it only have 3 marks, so and it also stated that you only need to explain the above reason. Okay, then in this case, we need to first think about from 0 degrees Celsius to 10 degrees Celsius, then what happening actually? So first of all, the first mark, it will be allocated that, okay, towards to the parts, okay, the explanation on it will be something in this way, okay? Under low temperature, the enzyme, okay? As the enzymes is inactive under the low temperature, so therefore, okay, once we increase the temperature, increasing the temperature, then in this case, as it increase the temperature, then in this case, we notice that both enzyme and substrate gain more kinetic energy. Okay. Therefore, more enzyme substrate complex will be formed. And for the last mark, it would be talking about the optimum temperature. Then when we talk about the optimum temperature, it is a must for us to write down which temperature it is. So in this case, the temperature would be 40 degrees Celsius. So the enzymatic reaction would be a limit. Sorry, would be at the highest. Okay. Okay, so in this case, we can see that, okay, and higher, higher test, it would be the highest, and as it reach the optimum temperature. Okay, so this will be the answer for the homework 2. So in this case, feel free to ask me in the Google Classroom if you have any questions, and good luck to your uniform test. So this will be the end of the briefing on the homework 2. Okay, so good luck. Okay.